Assalamu alaikum. Hopefully, he have taught you the theoretical portion of the project. Now, I'm gonna take you over the practical part of it, that is the coding part. So, basically, this is our whole VGA final project, and it has a total of five modules. First of all, we have the topmost module, and then we have the clock divider module, the horizontal counter, the vertical counter, and the Pong graph um module. So basically, the topmost module we have top.v, which is the topmost module and instantiates or calls the all of the other modules and actually is a controller for all of them. The other modules are lie downwards in hierarchy beneath the topmost module, and as you can see, each one performs its functions, takes inputs from the top module, performs their specific functions, and give their output back to the top module. So on the top module, as we know that in this VGA project, we want to display anything. It could be numbering like 1, 2, 3, or more specifically, what we want to do is we want to show a still Pong game image on the monitor using the VGA interfacing with our FPGA module. So the input output configuration is such that to drive any monitor using the VGA, first of all, we need a clock signal as an input to our module or our FPGA. Then we need a horizontal and vertical sync. Hopefully, my partner has explained you about these sync functions. So these sync functions establish a synchronization between the FPGA and the monitor cursor. Or, for example, like they tell the FPGA like where to place certain pixels over the monitor screen. All right. So then we have on our output 3-bit red, 3-bit green, and 4-bit red, 4-bit green, and 4-bit blue signals. So these basically each pixel is composed of a mix of red, green, and blue. Um, what we can do is out of the total 15 pins in the FPGA, we have dedicated 4 pins for the red color, 4 pins for the green color, and 4 pins for the blue color. Going on, we here declare some wires like the video on. For example, this one tells the FPGA that on the monitor before the original screen where we want to display our objects or our graphics. Where to actually provide the data. So basically, it specifies that currently the pixel that currently is being accessed is on the screen where we want to display the information or the graphics. So for that specific pixel, the video on signal will be 1, while for rest of others, the video on function will be 0. Then, of course, as you will know that for VGA purposes, we want to drive our FPGA using a 25 megahertz clock signal, except in contrast to the original 100 megahertz clock signal available on our Xilinx FPGA module. Then we have the enable vertical counter. This one is the horizontal count value, and this one is the vertical count value. And this one stores the RGB values in form of 3 bits: 1 bit for R, 1 for green, and 1 for blue. Then we instantiate our rest of the modules, that is the clock divider. What it does is basically we give it the clock, the original clock at the 100 at 100 megahertz, and it gives us back the reduced clock over running over 25 megahertz. So what it does basically, it has two always loops. Okay, I'm not gonna go into very much detail. So basically, it has two always loop, and the first always loops decreases the clock speed by half, while the other one decreases the clock speed up further by half. So thereby decreasing the clock speed by 4 times, thus giving us 25 megahertz from the original 100 megahertz. Okay, the horizontal counter VGA, this module does is we give it the slow clock, the 25 megahertz clock, the enable V counter, and H count value. Basically, it um, as you can see, it checks if the horizontal, because our monitor on which we want to display has a maximum horizontal pixels of 800. It just iterates from the pixel 0 to pixel number 800, and using the slow clock. And when the final pixel is reached, it resets the value, horizontal value, to 0, and uh, enables the vertical counter, so that the next vertical counter or the next vertical increment could be made. Okay, as you can see that it gives the enable vertical counter signal on its output, which we give to the vertical counter VGA on its input. So it tells the vertical counter that okay, your turn has now come. So what we want to do is we want to increment the vertical row from 0 to 1, or if it was previously 0, we want to increment it by 1. Going on the top module back again, we have instantiated our graphics operator. What we want to do is we want to give it the video signal, and we want to give it the horizontal pixel value, like for example, which horizontal pixel is our uh, cursor currently at, and which vertical pixel our cursor is currently at. And then we want then it will give us a value of RGB to display, and that what value of RGB color we should display at that pixels. And so as we iterate through whole grid of pixels of the monitor, it provides the RGB values of all the pixels. So just going into the function for a quick look. Basically, we first of all specify three different objects: the square ball, and the leftmost wall, and the rightmost, the the leftmost boundary, and the rightmost vertical bar. We specify the pixel number values where they should start and end in the horizontal axis, and similarly for the wall. This one was the maximum pixel value that could be reached, and so on. We specify the pixel values, and then we provide logic for making those objects whenever a pixel is reached, that is in where we want to place these objects. We make the logic to give some pixel value in the RGBs that it then sends to this top module. All right. So once we have our all our inputs and all our outputs from our other sub modules, what we do is we want to give the horizontal sync and the vertical sync signal to the monitor for synchronization and driving the monitor. For as you know that for 96 seconds, which is the retrace time, our cursor moves back from, for example, if this is the end of the screen, it takes 96 seconds, nanoseconds to come back to the start position. And so takes the vsynchronization function, or vsynchronization signal, that our pixels takes almost 2 nanoseconds to come from one column to the next incremental column. Finally, what we want to do is we want to create a video on signal that tells that we give here to the graphics submodule, that tells the graphics submodule that where in which pixel range we want to place our graphic values of red, green, and blue. Finally, as we know that the graphics submodule gives us the RGB in terms of 3 bits: 1 bit for R, 1 bit for green, and 1 bit for blue. And we see if the red bit is 1, then we actually supply a 4 bit um, 1111 to the red pins. Similarly, if the green bit is 1, we provide a 4-bit 1111, that is a value of 16 to the green bit, and same goes for the blue one. So finally, I would like to show you the I would like to show you the demo of this code. So I have already created the bit files. I just want to run the bit file so that you can see the output on the screen. As you can see, that I have uploaded it I have run the bit file, and here is our output for the Pong game, a still screen of the Pong game.